Hey, and welcome to today's webinar on API security, trends, challenges, and best practices. My name is Laura Payne, and I'm the Director of Product Marketing here at Invicti. I have 10 years of cybersecurity and enterprise tech experience, and I'm super passionate about helping people to feel safe in both physical and digital worlds. In my free time, I'm a hypnotherapist, but don't you worry, we won't be using any of those skills here today. Mark, do you want to introduce yourself?
Thanks, Laura, and welcome to today's webinar. I am Mark Schembri, based in Malta. I am a Solutions Engineering Manager at Invicti, a cybersecurity enthusiast with 20 years experience within the security and communication industry. Like Laura, I am very passionate about what I do, and along with Invicti, we make our space a safer one.
Thanks, Mark. As always, it is a pleasure to be here presenting with you today. So let's dive into today's session. First, we're going to set the scene and make sure that we're all on the same page. We'll dive into what APIs are and why securing them is so important. Next, we'll take a look at some of the challenges of securing APIs, and we'll close out the session with some of the best practices that we have to offer. Before we do that, though, I want to quickly introduce you to Invicti. Invicti has been a global leader in web application security since 2005. We help more than 3,000 customers around the world of all sizes and in all industries to secure all of their web applications, both in development and in production. We offer dynamic application security testing, or DAST, interactive application security testing, or IAST, and software composition analysis, or SCA. And we do this with automation, scale, and accuracy.
So on today's topic, web application programming interfaces, or APIs, present a huge, yet still underprotected, attack surface for cybercriminals. While application security testing has traditionally been focused on the user interface, modern applications rely heavily on APIs for data exchange and to build the application architecture. Today's enterprise web apps are no longer monolithic applications, but more like constellations of loosely coupled services communicating through APIs, all subject to rapid development in response to shifting business requirements. And each is a target in its own right. The ability to quickly build and expand applications using APIs is crucial for innovation and business growth. But it can also dramatically increase the web attack service, leaving organizations exposed to attacks. More and more, a graphical user interface is just a way to retrieve data from APIs and present it to users. In modern service-oriented architectures, most, if not all, application functionality is implemented as web services and exposed through the APIs. In effect, APIs are the gatekeepers of the world's business logic and data. And with the data being the most valuable resource, it is no wonder that API-based attacks are on the rise.
In fact, both web apps and APIs are a big source of risk to organizations, and the problem is growing. So let's take a closer look at the latest stats. According to the Akamai 2021 State of the Internet report, 83% of all web traffic is now API call traffic. The Verizon Data Breach Investigations report shows us that web applications are targeted in over 39% of attacks that resulted in successful breaches. The volume of APIs is multiplying as organizations accelerate digital transformation and adopt modern application development approaches. According to the Cloud Security Alliance, the average enterprise deploys 434 custom apps because web apps are becoming the primary means of communication with customers, partners, and employees. And a record number of web vulnerabilities were reported in 2021, putting this year on track to break the 20,000 mark for the first time. The latest figures from Gartner state that API abuses will become the #1 attack vector this year. This confirms that in order for organizations to effectively protect against web attacks, application security testing must be prioritized, and it must also cover APIs. If you want to avoid becoming the next breach headline, there is no question that you need to test and secure your web applications in their entirety, including both UI and API, because cyber criminals will find the weakest spot and strike there. But while web application security testing is already a fairly mature segment, API security testing is still playing a little bit of catch up. And there are many misconceptions and misunderstandings to clear up around testing the API part of the web attack surface. So let's look at this in more detail. Part of the reason for the rising tide of API based attacks is that many organizations are still not sure what web APIs they have, what they should do about them, and what questions to ask when investigating API security. Mark, let's take a look at some of the questions that arise.
Absolutely. Let's start by asking, what are these APIs? Let's start by going through some definitions. An API is a connection between software functionality and another system or another application. An API is an interface for accessing web-based software. There are many architectures and standards, the most widely used model being the REST model. An API endpoint is a URL for calling a specific web API. It is a specific address where API requests and parameters are sent. As an interesting fact, the first production example of a web application programming interface, or API, was created by Salesforce.com back in the early 2000s. Originally, it was meant as a relatively simple system-to-system communication method, which then evolved into one of the biggest drivers of internet traffic today. So what makes APIs so attractive to malicious hackers? There are a number of reasons, but let's look at the main four. First, API creators are expecting well-formed requests from known systems, so they are less likely to check incoming calls with the same care as for user-facing pages. Secondly, many APIs start life as private APIs that are intended for testing or internal use only. These can later slip into production, often without inventory, documentation, without logging, or access control. Thirdly, web APIs are designed with automated access in mind, which is convenient for both valid users as well as for the attackers. And lastly, API endpoints are easy to define but hard to find, hard to test, and secure. So all the above makes APIs a fast-growing vector for cyber attacks with their many possible consequences, from data breaches and denial of service to ransomware deployments.
There's also a lot of confusion around the concept of API attacks. Could you please help us demystify these, Mark?
Sure. Let's start by understanding the difference between attacks on APIs versus attacks via APIs. Well, to simplify this, attacks on APIs are about getting access to the interface itself, whereas attacks via APIs are about using API access to attack the underlying application.
Thanks for that. Can you give us some examples of how APIs work?
Yes, let's go into that. You could say that APIs are really the glue that holds together the entire modern web. First off, web-facing applications can have an external API that allows other software to interact and integrate with the application. As an example, Invicti's own API makes it possible for our customers to integrate vulnerability testing into existing workflows and customize out-of-the-box integrations where necessary. Then you have APIs in service-based applications. In this case, API calls are used for communication and data exchange between the application components. And another typical use for web APIs is to provide a standalone multi-purpose backend. You can then have a single backend that serves data to many different frontends via API calls. This is how many mobile applications work, where the application is then just a user interface that calls backend APIs.
Okay, got it. So how should we go about securing these?
Well, as I've mentioned earlier, the original use case for adding them was to extend access to application functionality beyond the graphical user interface, most notably for integrations and automation. With the move to service-oriented architectures and agile developments, APIs and the services behind them are now the fundamental building blocks of modern web applications. In terms of security, as we've seen, the web application has gone from one big target to hundreds of little targets, and that means hundreds of potential entry points to defend. Here on the slide, you can clearly see the difference between a monolithic legacy app and a modern web application. Having a distributed architecture gives malicious actors much more freedom to conduct attacks on a massive scale with less risk of detection. In fact, even monolithic legacy applications will often have an external API for integration and data exchange. And this API also contributes to their attack surface. Modern web applications can both have external facing APIs and be themselves made up of dozens of microservices, each with its own API. Again, all this contributes to the overall attack surface that you need to test.
You're spot on, Mark. After all, why would cyber criminals waste their time trying to hack a login form when they can quietly extract the same data through an API, right? I'd like to start talking about some of the challenges we are seeing out there. We can split them out into three categories: people, process, and tech or tooling. From the people perspective, as we learned from the Invicti Fall 2021 survey, up to 70% of development teams will skip some security steps when time is short. And this is likely to include API testing. Developers will often perceive APIs as internal assets and assume that they are less of a security risk compared to user-facing interfaces. From a process standpoint, unless it is deeply embedded into development and testing workflows, API security can slip out of mind when time is short and release deadlines loom. APIs may simply be harder and more time-consuming to find, document, and test. And when we consider tech and tooling, if a separate toolchain is needed for the API part of security testing, this increases the risk of vulnerabilities slipping into production as a result of missing or incomplete testing. APIs can change and expand much faster than user-facing interfaces. This can make purely manual testing impractical and strengthens the case for relying on efficient and accurate automated scanning solutions. While APIs use the same web technologies as websites and web applications, most general purpose vulnerability scanners or DAS tools will be unable to recognize and test all the endpoints, potentially leaving unacceptable security holes. One thing is certain: if you have web applications, you already have APIs somewhere in your web attack surface today. So let's look at some of the industry best practices to see how we can incorporate API scanning into an overall AppSec program to help you reduce the risk of exposure. You want to take us through it, Mark?
It will be my pleasure, Laura. So there are a few steps we recommend. The first step is to get the API definitions so you know what you need to test. Also, integrate API testing into your development lifecycle. Also, ensure consistent test accuracy across the entire application. And lastly, enforce authenticated scanning. Every day, enterprise applications are being rapidly assembled from dozens of services or hundreds of microservices, all communicating through APIs. To make sure that these modern applications are fully covered by security testing, the logical next step for web application security was to extend vulnerability scanning to also include the APIs. But that required advanced technical solutions and efficient workflow integration. Invicti provides a single platform for comprehensive web application security testing, covering both the visible and the hidden parts of your web attack surface. As you are using our industry-leading scanning technology in development and production, you can also ensure that your APIs are subjected to the same level of vulnerability testing. All this is integrated into your existing workflows without clunky add-on toolchains or waiting for external security testing. You now have all you need to scan and continuously ensure that your entire web attack surface is secured. So get to it before the next attack comes. Here is a quote from one of our customers, for whom covering APIs as part of their vulnerability scanning was very important. They were impressed particularly by the platform's ability to cover GraphQL APIs. This is another use case, just highlighting the ease of use of our platform when it comes to including scanning of our APIs as part of your testing. These are two of the many users who trusted Invicti with their API scanning to make sure that all their assets are kept safe and secure.
Thanks for walking through all of that with us, Mark. I really appreciate it. And at this time, I'd love to open it up to questions from the audience.